All right. So that's the easy one. Let's try a little bit harder. Let's try this one. The velocity is not constant. The velocity initial is 10 meters per second. But Christian lets go. Christian's not pulling. What's the net force on that object now? Look at the free body diagram I ended up drawing. You see that? All right. So now, guess what would happen if we did the vertical? Same thing, right? But now, horizontally, what are you going to do? Which way is positive? Let's say this way is positive. I can say anything I want as long as I'm consistent. To the right is positive, all right? It's not the winner, but even if you don't pick the right way, it works. So tell me what to write down in the x direction. The sum of all the forces in the x direction causes the mass to accelerate in the x direction. Now, let's sum all the forces up in the x direction. All right, here we go. Ready for friction. Let's try it again. Ready, friction. See? Let's sum up all one of them. Friction. And it's negative or positive if I said to the right was positive. Negative. So minus friction, did I sum all of them up? Yep. Equals ma. So guess what this object is going to do? If friction is the only force acting on it horizontally, what's it going to do? It's going to slow down or decelerate. Yeah, you're both right. So you end up with friction. And did you guys get to the part of the chapter where you learned about mu? No? Get there soon. Okay? So friction equals ma. Now I can't go further unless somebody told me how much friction there was. Okay? If friction was 5 newtons, then 5 newtons equals ma. If this was a 2 kilogram mass, and that was 5 newtons, I would be able to find out the acceleration. And Dave, I'd get a negative answer. What does that mean? It decelerated, or doesn't necessarily mean it decelerated. It means it's the opposite way that I said was positive. If I said to the right was positive, I get a negative a. You know what that means? It's accelerating to the left while I'm moving to the right. Isn't that cool? It doesn't mean I'm slowing down, because what if I'm moving to the left and I'm accelerating to the left? Now I'm going faster in reverse. So negative doesn't mean you're slowing down. It just means you're accelerating in the opposite direction that you're moving. You're accelerating in the opposite direction of what you said was positive. Watch. Here's gravity. Which way is gravity? Down. Which way do I want to say is positive? Up. So what's gravity? Negative 9.8. Why? Because I said up was positive. Now watch. If I shoot it up, gravity slows it down. But when it stops, and the acceleration is still 9.8 at the top, by the way, if it starts coming back down, now is it now negative velocity, negative acceleration, now it's speeding down. I don't want to say speeding up. It's accelerating downward, so it's in the same direction, it's going faster. Okay? All right. So you don't know mu yet, so we're going to hold off on that. But one more crazy one. Draw all the forces acting on that block. There is friction, gravity, and the normal force. Draw all the forces acting on this block. Let's just stop that tape for a second.